Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to figure out how much mass of a particular metal was dissolved in HCl when you're only given the initial concentration of the HCl and the final concentration of the HCl. So let's get into this. So in this problem, we are given a small piece of zinc, and we're told it dissolved in 50 milliliters of a HCl solution, 1.050 molar. At the conclusion of the reaction, the concentration of the 50 milliliter sample is redetermined and found to be 0.776 molar HCl. What must have been the mass of the piece of the zinc that's dissolved? Okay, so how do you attack this problem? So the first thing you want to think about is the difference in the molarity of the HCl, right? So the difference in the molarity of the HCl is because of the reaction with the metal. So the metal has reacted with some of the HCl in the solution and therefore removed some of that HCl, and that's why you see the concentration go down. So all you need to do for this problem is calculate the molarity, or I'm sorry, calculate the moles of the HCl that was in the original solution, calculate the moles of the HCl that was in the solution after the reaction, and then since you have the moles before and after, find the difference in the moles, and then that'll give you the number of moles of HCl that reacted with the amount of metal you put into the solution. Once you have that, it's stoichiometry from there. I'm going to take the grams of the metal, the grams or the moles, in this case, the moles of the HCl that reacted, and convert that to grams of zinc metal that reacted. So let's go ahead and do that. So you have a piece of zinc metal, you have 50 milliliters. So I'm going to start with 50 milliliters of the HCl. 0, 0, so 50 milliliters of the HCl solution over 1. And I'm going to use the molarity as a conversion factor. Anytime they give you molarity, think conversion factor. It is a possible conversion factor because molarity allows you to convert between moles of the substance in a solution and the volume of the solution. So you can use that to convert between those two. Here we're given volume, and molarity, if you remember, is moles per liter. So if we're going to use the molarity as a conversion factor, we need to convert milliliters to liters. So I know that 1 milliliter of the HCl solution is equal to 1/1000th or 10 to the negative 3 liters of HCl solution. Or you could have used 1,000 milliliters is equal to 1 liter. It's the same ratio. Here the milliliters are going to cancel out. And now I have liters. Now I can use molarity as a conversion factor. So in this case, I'm going to start with 1.050 molar HCl. So what that means is that I have 1.050 moles per liter of the solution. So since I have liters on the top, I'm going to have liters on the bottom. So 1 liter of the HCl solution. And then on top, I'm going to have the 1.050 moles of HCl. So the liters of HCl solution cancel out, and now I have moles of HCl. So now all I need to do is calculate the number of moles. So all I need to do is multiply across the top, divide by what's in the bottom, and I get my answer. And when I do that, I get 0.0525. So 0.0525 moles of HCl. So this is the original amount of HCl that was in the solution before I reacted it with zinc metal. Now we're going to calculate, same exact way, we're going to calculate the amount of HCl in the solution after we reacted with the zinc metal. So here's the molarity afterwards. We have the same volume, so the volume we're told doesn't change. So we're going to start with, again, 50 milliliters of the HCl solution. And I'm going to put over 1. And I'm going to do the conversions. So again, if I'm going to use the molarity, I need liters. So I'm going to convert this to liters. Again, 1 milliliter. How do I know that 1 milliliter is 1/1000th of a liter? It's because milli means 1/1000th. So 1 milliliter is 1/1000th, or 10 to the negative 3 liters. So this is HCl solution. HCl solution. So milliliters are going to cancel out. Now I have liters of the HCl solution. And now I'm going to use the molarity to convert to moles. So I'm going to use the 0.776 molar. So on the bottom, I'm going to put 1 liter again, 1 liter of the HCl solution. And on top is going to be 0.776 moles of HCl. So liters are going to cancel out. Now, again, all I need to do is multiply across the top, divide by the bottom, and I'll get the number of moles. And when I do that, I get 0.0388. 0.0388 moles of HCl. So now I have the number of moles of HCl that was in my solution before I reacted the zinc. I have the number of moles of the HCl that was in solution after the reaction. So this is before, after. So how much was reacted? I just subtract. So I'm going to take the 0.0525 moles of HCl that I started with. I'm going to subtract the 0.0388 moles of HCl that I ended with. And when I subtract that, I get 0.0137. 0.0137 moles of HCl reacted. So now that I know the amount of moles of HCl that reacted with the metal, now I can do stoichiometry to convert the number of moles of HCl reacted to the number of moles of zinc, and then to the mass of zinc. But I need a balanced equation. Now, they could give you the balanced equation, but you could figure out the balanced equation yourself, because we know that zinc is reacting with HCl. If you remember your types of reactions, if you have a compound with an element as reactants, that indicates a single replacement reaction. So we can write that here. So zinc solid is going to react with HCl aqueous. So in this case, zinc is going to form positive ions. H is a positive ion. That'll form positive ions. So the zinc is going to replace the hydrogen, and so you're going to get zinc chloride. So zinc is going to have a 2+ charge. So we need 2 chloride ions to balance the charge on the zinc. So there's our formula for a 1 product. And then we get hydrogen left over. So then we're going to get H2. We have to remember that hydrogen is a diatomic molecule, so we need to write H2, not just H, right? So if you want to remember the diatomic molecules or diatomic elements, remember the phrase horses need oats for clear brown eyes, right? So each letter at the beginning of the word represents an element on the periodic table. So horses, H, need, N, nitrogen, oats, O, oxygen, right? Horses need oats for fluorine, clear, chlorine, brown, bromine, and eyes, iodine. Okay, so now we got to make sure this is balanced. We have zinc. Let me double check something really quick. Yep. So we have one zinc, one zinc. We have one hydrogen. We have two hydrogens here. So we'll need a 2 there. So we have two hydrogens. And now we have two chlorines as well. So now we have our balanced equation. So now I can use stoichiometry. So I'm going to start. I know this is the amount of HCl that reacted. So I'm going to start with that. So I get 0.0137 moles of HCl reacted. And I want to find out how much zinc was there. So now I'm going to use my mole ratio between the HCl and the zinc. So I have two moles. For every 2 moles of the HCl that react, 1 mole of zinc reacts. So that's my mole ratio. So on the bottom, I'm going to put 2 moles of HCl. And then on top, I'm going to put 1 mole of zinc. So the moles of HCl cancel out. Now I have moles of zinc. And next, I want grams because they're asking me what is the mass. So I'm going to get the mass in grams. So I'm going to use the molar mass to convert. So I look up the molar mass of zinc on the periodic table, 6538. So I'm going to put 1 mole of zinc on the bottom and 65.38 grams of zinc on top. Let me just double check that really quick. 6538, yeah. So now moles are going to cancel out. Now I have grams of zinc. That's what I want. That's what they're asking for. So now all I need to do is multiply across top, divide by the bottom, and I get my answer. And the answer is 0.4478. 0.4478 grams. However, got to pay attention to sig figs. I have 4 sig figs here. I have 3 sig figs here. So my final answer should only have 3 sig figs. So I got 1, 2, 3. Cut it off after the 7. I have an 8 here. So that means I have to round the 7 to an 8. So I get 0.448 grams of zinc. So that was the mass of my piece of metal, zinc metal, that I put into the 50 milliliters of HCl. That, ladies and gentlemen, is how you do this problem. I hope you enjoyed this video. If you enjoyed this video, if you learned a lot from this video, if this helped you in any way, then please like the video. Hit that like button somewhere over here or somewhere around here. Also, make sure you help me out here. Subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if there's a topic you want me to cover, put that down below. I would like to do that for you. Thanks for joining me, and have a great day.